Hi, this is Adam Griffin with the second video for this week, and we are going to be doing problem number 4. So it goes like this. Consider a galaxy that is dark matter dominated, and the mass of stars can be ignored for this problem. And we have a few visible stars in circular motion rotating through the dark matter around the galaxy's center with radius r. For this problem, suppose the dark matter has a spherical shape and uniform density p, and that masses of other objects can be neglected. Also assume that the radius of the dark matter cloud is greater than the star's orbital radius r, and we have to answer how do the velocities of these stars depend on their distance from the galactic center. So it also says that we have to keep in mind that in this case the relevant mass for the gravitational force on the stars is the mass of the dark matter contained in the sphere with radius r and the radius of the star's orbit. So basically what it's saying is that we have stars orbiting some point, the galactic center, and their distance from that is equivalent to saying that they are rotating a mass with radius r, and they are on the surface of it. And the entire, that is a sphere with radius r, and the density of that sphere is p. So wherever the star is the radius of that sphere of dark matter. So we also have to note that dark matter halos of galaxies have a more complicated dependence on r, and you may find it useful to contrast the case described here to start orbiting a galaxy where almost all of the mass is concentrated at the galactic center. So we don't really need to pay attention to that last part, but we get from Newton's second law that the velocity of something orbiting another object is equivalent to the square root of our gravitational constant times the mass of whatever our object is orbiting divided by the radius that it orbits at from the center of the object. So if we have a sphere, which we do, of dark matter, we have to find the volume of the sphere to relate it to the density and find the mass. So we get that the volume of a sphere, the equation for the volume of a sphere is 4 pi r cubed divided by 3. And we can draw out that sphere really quick. We have our star right here at some radius r from the galactic center. And r is also the radius of the sphere of dark matter. And the star is rotating or orbiting around this sphere on the surface at some speed v. So because mass equals our density times our volume, and we know our equation for volume of a sphere, we can take that and turn it into our density times 4 pi r cubed divided by 3. And then plug that in for where the m is in Newton's second law. So we get that our velocity related to this radius is just the square root of our gravitational constant times our density times 4 pi times our radius squared divided by 3. So that is how you do problem number 4, and thank you.